Hi everyone. In this video we're going to go over some of the rules that you kind of discovered in today's investigation, but we just want to make sure everyone's got these rules straight. So before we dive in, I want to go over some vocabulary that's going to be really important in this chapter. And so there's three words that we really need to be familiar with. So the first word, and I'm just going to kind of write this at the top here, the first word when we're working with exponents, we want to be familiar with the base. And for us, the base is the thing. So sometimes it'll be a number, sometimes it'll be a variable. So the thing, either a number or a variable that is being multiplied. So when we're working with exponents here, we're talking about multiplication. So the base is the thing that's being multiplied. That should say multiplied, not multiplication. Sorry about that. Okay, so the thing that is being multiplied. So in our first one, we have our base is the x. And our second expression, our base is the 2. And our third, the base is the a. To help me remember, sometimes I think the base is the thing at the bottom. So that might help you out. Now, the second word is the exponent. And the exponent tells us how many times the base is multiplied by itself. So the exponent tells us how many times we're going to take that base and multiply it by itself. So in our first expression here, the exponent is the 3. Here the exponent is the x, and here the exponent is the b. Now, notice, just like we could have bases that were either a variable or a number, we can have exponents that are either a number or a variable. So now when I look at my first expression, this is going to tell me take that base x and multiply it by itself 3 times. So this is the same as x times x times x. So in terms of vocab, the last thing we want to be familiar with is the word power. And really the power is the whole thing, the base and the exponent together. Okay, now there's a note here. It says if you can't see the exponent on a number or a variable, then the exponent is automatically equal to 1. So in this example here, what we're saying is if I have the expression 2x cubed, remember we can say this x to the third or x cubed, since I don't see an exponent on the number 2, that means that's the same as 2 to the 1 times x cubed. So if I were to write this out the long way, that says take 2 and multiply it by itself once. So I just have 1, 2. And then this says x has, I have 3 of them, so I'd have times x times x times x. That's how I'd expand that out. So the thing we want to be careful of is since the 2 doesn't have an exponent, we only have an exponent of 1, so I only have 1, 2 here when I expand it. All right, so then we went into some rules investigations here. And so we're going to summarize what happened in our investigation. All right, so for the first one, we have x to the 5th times x cubed, and it's asking us to simplify that. So we're going to go ahead and expand that out first to see what's happening. So I first see I have x to the 5th, so that means I have 5 x's. X times x times x times x times x. So there's my x to the 5th. Now here I have times x cubed, or x to the 3rd. So that means I have x times x times x. Well, if I look at that whole expression, I have 1, 2, 3, 4, 5, 6, 7, 8 x's, so I can simplify this as x to the 8th power. So the pattern I'm noticing is that we are going to add the exponents when the bases are the same and we are multiplying. So there's a few key things here. Notice we said when the bases are the same. So the only reason we could add because the base here was an x and the base here was an x. If those bases were different, we couldn't just add up the exponents. And again, this rule applies when we're multiplying because we had x to the 5th times x cubed. So if I wanted to write a general rule, it looks like this. X to the, we're just going to call it generically the nth power, times x to the m. If we simplify that, our base would stay the same and we would have x, and then we would add our exponents to the n plus m. Notice my base is always x, and then to get my exponent, I'm just adding those exponents together. So that was our first rule. Then we looked at what happens if we divide. So over here, I'm going to start out the same way just by expanding it, kind of like we did in the investigation. So this x to the 5th tells me that I have 5 x's. So x times x times x times x times x over my x to the 3rd power here tells me I have x times x times x. Now, I'm going to be able to cancel if I have the same thing on top and bottom. So I can cancel these x's, I can cancel this, and I can cancel this, which leaves me with just my 2 x's on top, which is going to give me an x squared. So now the pattern I'm noticing is that I'm going to subtract the exponents when the bases are the same. Again, this is only when the bases are the same. So when the base is the same and we are dividing. So now, if again we're looking for a general rule, if I have x to the n over x to the m, now in this case my base is going to stay the same, but I'm going to subtract those exponents. I'm going to start with the 1 on top and subtract the 1 on the bottom. So those are the 2 rules we have so far. So let's go ahead and turn the page and do a few examples. And again, we won't do all of these. Sorry, this is kind of messy because my pen bled through. Let's see. We'll do, I think, the first 3 and we'll save the last 3 for class. So let's go ahead and take a look at what's happening here. In our first problem, we have x to the 5th times x to the 6th. So the first thing I notice right here is that I'm multiplying, so that sounds like a rule we have. And I also notice that our bases are the same. They're both x. So we said our rule is the bases are the same and we're multiplying. We're going to keep that same base and we're going to add the exponents. So I'm going to make a note here. We're going to add our exponents. So 5 plus 6 is going to give me x to the 11th power. Now, I could check this by doing my work the long way. So first we have x to the 5th, which means I would have x times x times x times x times x times x to the 6th power, which means I have 1, 2, 3, 4, 5, 6. And so if I added all of those up, I would have 11x multiplied by itself 11 times, which is x to the 11th power. So just two ways of seeing how that works, using our rules first and then kind of using the long way and checking that we get the same thing. Now in number 2, I see that I have division this time. So my operation is division. But again, I still have the same base, which is going to help me out here. Here it's y and here it's y. So we said in this case, if we have the same base and we're dividing, we're going to subtract the exponents. So now my base is going to stay the same. Remember we said here the exponent is 8. Here we said if we don't see one, it's just an exponent of 1. So 8 minus 1 is going to give us 7. So we have y to the 7th power. And again, you can always think about this the long way. Y to the 8th means I'm multiplying y by itself 8 times. So I have 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I have to count those out so I keep track of it. We knew we were dividing. And then on the bottom, we had y to the 1st power, so just 1y. Now, I can cancel 1y on the top with 1y on the bottom, which leaves me 1, 2, 3, 4, 5, 6, 7. So our simplified answer, again, matches y to the 7th. All right, we'll go ahead and do one more. So number 3. So let's take a look at what's going on. I see I have multiplication. I see that my bases are the same, x to the 4th and x cubed, but I also have this 3. And we learned on the first page, if I don't see an exponent, that means it's exponent of 1. So now this 3 has to stay by itself because it doesn't have the same bases as these two exponents, so I can't add all 3 exponents. So my 3 is just going to stand by itself. Now when it comes to deal with the x's, since they have the same base and we're multiplying, we're going to add those exponents. So we get 3 times x to the 7th power. If we're going to check our answer using the long way, we said this had an exponent of 1, so we just have 3. X to the 4th is going to give us x times x times x times x. And then x cubed is x times x times x. So if I were to simplify this, I still have my 3, it has to stay. But I have 1, 2, 3, 4, 5, 6, 7 x's, so this is x to the 7th power. So whether I use the rule or whether I expand it out and then simplify, I get the same answer. So we'll leave the video at that for now. We'll go over 4, 5, and 6 when we start class, just to make sure everyone understands and feels comfortable, and then you'll have some time to practice with these rules. All right, make sure you've got good complete notes, and I will see you back in class. Thanks.